Let's review the Pythagorean theorem, which you may recall is often just said a squared plus b squared equals c squared, but really there's a little more detail involved in it. The Pythagorean theorem only applies if you have a right triangle, and we'll call the short side s, the medium side m, and the long side l. And in that case, you'll have s squared plus m squared equals l squared. So let's find the distance between the point 5,4 and the point 11,7. So we'll make a quick sketch of those 2 points here. So we've got 5 comma 4 and 11 comma 7 right here. And so if we want to find the distance, we'll just connect these 2 points with a straight line. We want to find out how long that line is, right? That would be the distance. Well, do you see a right triangle in this picture? It'd be really nice for us to be able to use a Pythagorean theorem. So we want the value of this distance. There is a right triangle that's hiding in the picture. You just need to draw some extra edges. So we drew them in dotted here. And in order to apply the Pythagorean theorem, we're going to need to know what this distance is down here and this distance is there. So the one that's across here, well, just follow this down here from x equals 5 all the way going up to x equals 11. That distance should be 11 minus 5. That's distance is certainly 6. We'll just leave it written as 11 minus 5. And then the vertical distance here, well, starting from y equals 4, headed on up to y equals 7. Think about if you're on the 4th floor and you have to head to the 7th floor. How many elevator floors do you need to go up? That's got to be 3 floors, right? So 7 minus 4. And so if we set up the Pythagorean theorem, the hypotenuse squared, so d squared is equal to this side squared. So we'll just still write it as 11 minus 5 quantity squared. And then this side squared, so 7 minus 4, that's the side. And then we have to square it, right? Because that's m squared, right? Okay. And then to get the distance itself, we're just going to need to square root both sides. That will introduce a plus or minus sign. The thing is that it only makes sense for distance to be positive, and we didn't simplify it all, but this is an expression that represents the distance. Please remember that the square root sign does not distribute, so it would be incorrect to take the square root sign and then have it cancel out with this square here and there. Let's apply the same process that we just looked at. That specific example can actually be generalized. So now let's find the distance between 2 points where we weren't given the coordinates of any of the points yet. Just in the interest of making a formula, there's a point that's called x1, y1, and a second point which is x2, y2. So take those 2 points. We want the distance between the 2 points, so we'll label that d, the length of that line segment. There's again a right triangle here. And that horizontal distance is x2 minus x1, and this vertical distance is y2 minus y1. We'll set up the Pythagorean theorem. Yeah, so the hypotenuse squared is each of the side lengths squared, and each of the other 2 dotted side lengths are a subtraction of x coordinates or a subtraction of y coordinates. Now to find the distance, we need to square root both sides, but it doesn't make sense to have a negative distance, so we'll say that d is equal to square root of, now removing the plus or minus sign, d is equal to square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Just recall again that the square root sign does not distribute. And so what we have made here is the distance formula. So the distance between a point 1, which would be x1, y1, and a point 2, which would be x2, y2, is d is equal to square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, just some comments about this formula. Trying to simplify that, what the distance formula gives, to either distribute the square root sign like this, or after distributing, having the square root cancel the square. I mean, that part would work. It's just the first step doesn't work out. The point is, all of what's shown in red really doesn't work because it's using a false formula. So the distance, the distance formula as presented is the distance formula. You cannot simplify that any further by trying to distribute a square root sign or cancel the square root with both of the squares or anything like that. Just keep in mind the distance formula comes from the Pythagorean theorem. Knowing that the distance formula comes from the Pythagorean theorem will help with remembering the pieces of it, because it does look funky, right? So take a look. The distance formula has a plus sign, and it has 2 minus signs. Know where everything comes from. So the plus sign that shows up in the distance formula is really the plus sign that showed up in the Pythagorean theorem. The 2 squareds appear because the Pythagorean theorem, remember, a squared plus b squared. What about why is there a huge square root sign? It's because in the Pythagorean theorem, you had the hypotenuse squared, what we often call c squared, but we wanted the distance itself. We wanted d itself, so we had to get d, we had to square root both sides. That's why there's this huge square root sign left on one side. Okay, so now let's apply the distance formula to find the distance between these 2 points. So just direct application of the formula says that the distance is square root of a sum, and what is that sum? What's on one side of the plus sign is the square of the difference of the x coordinate, so 1 minus 3 quantity squared, and then after the plus sign you have the square of the difference of the y coordinate, so 8 minus negative 4 quantity squared. Don't distribute the square root sign, that's made up stuff. Instead you could simplify what's in parentheses, so root negative 2 quantity squared plus 12 squared. That'd be root 4 plus 144. Again, here is again not a place to distribute the square root. This would be root 148, and 148 actually has a perfect square as a factor, so 148 can be written 4 times 37. That's still all inside the radical. Then split up the radical. So a radical does split up across multiplication, just not across an addition. And then the root 4 can be replaced with a 2. So you have 2 root 37. Okay, you might skip writing root 4 times 37 and root 4 times root 37, jumping directly from root 148 to 2 root 37. But I just wanted to show all the steps here, especially wanted to show the part that really uses the formula root AB equals root A times root B, because again, people sometimes try to do root 4 plus 144 equals root 4 plus root 144, which does not work, right? It is incorrect to turn root 4 plus 144 into root 4 plus root 144, or further into 2 plus 12. That would be using the false formula.